Okay, so in this video, I'm just going to give you a few clues about making your model, right? So actually, I just might try and shrink this down a little bit. Can I do that? And just so that we can see. Oh, I've just realized that I don't have my 0. No, I don't. So I'm actually just going to type that in there. Do make sure that you've got all your points. So I'm going to put that 0, 50 there. It's a strange place on my table. But now I've got all my points that I recorded from the dice simulation from my table. They're now into Desmos, right? Now, so the next thing we need to do is to use Desmos to make a model. So we need to type y equals, and we can see this is an exponential curve. So it's going to be a. Now I'm going to bring up the keyboard, and I'm going to use the times button because it's a times b to the power of x plus c. That's our normal exponential model. And I've got the screen line here. I think I'm going to change it to red so it's easier for you guys to see. So I do that in exactly the same way as I did before, by just holding so that I bring up the menu. And at the moment everything's set to 1, and I've just got this basically a y equals 1 line on my graph. It's obviously not a very good model. But before I start to use these sliders, let's think about what each of these letters really represents in a real life model, or what we know about exponential curves. The first thing is the C here, and I hope you're all like going, it's the asymptote, miss, because that's exactly what it is. Now in this case, I want you to think about, like, we've got 50 radioactive atoms, and if we've got an endless amount of time, how many are we going to end up with? Like, what's our asymptote here? And I'm kind of hoping that you'll be thinking to yourself, it's got to be 0, right? That's the minimum number of atoms that we can have. And it's not, this is a model. We want to, in real life, we'd want to ultimately get to 0 atoms, but also in real life it could take a really, really long length of time. So we're going to set our asymptote at 0. Okay, now the B is the base. It determines the shape of our exponential curve, and we're going to look at that last. So what about the A? If we make x equals 0, then b to the power of 0 is going to equal to 1. C is 0, we know that. So then y is just equal to a times 1, right? So when x is equal to 0, what should y equal? And I'm hoping you're thinking to yourself, that's at the start, how many dice did we start with? And of course, we started with 50 dice. So I'm actually just going to just not even bother to use the slider. I'm just going to write in A is equal to 50, right? So now I have a a horizontal line. I can get rid of my keyboard. I've got a horizontal line, and what I'm going to do now is I'm going to use my slider with B. It's the only thing I have to play with to try and get this red line to match my purple dots. So let's try that. Oh, okay, and let's just play with this a little bit more. Notice that, okay, if I go over 1, it flips the other way, and I need it to be between 0 and 1. Now, you don't have to do this. You might find it easy enough to do it, but I'm actually just going to click into here and put constraints on my slider, because I know it has to be between 0 and 1, and it just is going to let me fine-tune this. Okay, I am going to say, okay, now it's a model, right? And you can see I can either draw my curve here, where it fits nicely at the bottom, or I can move my curve to here, and it fits nicely at the top. I think I'm just going to try and compromise a little bit and just get, I'm just going to say that, right? So there's my curve. This is my model, and I'm going to retype it so you can see what it looks like. I'm going to go into here and type it. It's y equals, so instead of typing A, I'm going to type the 50. I need, whoops, I need my keyboard again to give me that multiply sign. Drop it away again. And my base is 0.77. Whoops, wrong button. 0.77 to the power of x. And I can write plus 0, yeah? Or I can just ignore that completely. And this is the same color, so I'm actually going to make this dotted, and I'm going to make it blue so that you can see, or maybe green, that it's the same as my red line. So there's my dotted green line. If I hide it, it's the same as my red line, right? So that's my model for my four-sided dice. Now, one of the questions that I'm going to be asking you to do is to find the half-life of your model, right? Now, the half-life is the time it takes to reach for the number of atoms, or in this case the number of dice, to decrease by half. Now, I started at 50 dice. So what I'm going to do, so my half-life is going to be when my curve is at 25 dice. Now, I don't have 25 on my table, and even if I did, I wouldn't want to use my table as my value for my half-life. This is what my model's for. So what I'm going to do is to find the value here on my graph when y is equal to 25, is the easiest way to do that on Desmos is simply to type a line, y equals 25, and then find the point of intersection. Desmos makes that really easy for us to do that. So y equals 25. Why have I said 25? Because that's half of my starting number, right? This is going to tell me my half-life. And now, when I click on that point of intersection, it should come up, and when it's kind of really stable like that and doesn't like flash down again, you get this kind of black box around it, you know you've got your exact point of intersection. So this is telling me, okay, it's telling me I have 50 dice, that's my half the quantity. And what is the time? What's the x value? It's 2.65 throws. So in other words, if I was to start with, let's say 200 dice instead of 500, then it would still take 2.65 rolls for 200 dice to become 100 dice. That's what half-life is. Okay, now, so what's the only other things? And like once you've got that, you can, once again, let's just try and do this. I can hide that horizontal line. And now I think the next thing I asked you to do was to take a screenshot and put it into your Google Doc. So I'm just going to play around a little bit so that you can see this on the video. Okay, I'm just going to use on my Mac the keyboard command to do a screenshot is Command-Shift-4. So that's actually what I'm doing right now. And you get a cursor that you can move anywhere. Now I want you to make sure that you get the labels on the graph. So I'm just going to bring it up here and I'm going to select through to here. Right? And when I let it go, by default on my computer, it just goes onto my desktop. It just saves onto my desktop. So now I'll show you how to get that into your Google Doc. Okay, so here's my Finder, here's my screenshot here, and literally all you have to do is just drag it in. And look, there we go. There's the screenshot. Now, you're going to need to give it a title. This is four-sided dice. Okay, so that's pretty much it. So you're doing, so just the instructions I hope are pretty clear, but you are doing, first of all, a six-sided dice complete model, data into Desmos, make a screenshot, make a model, mathematical model, take a screenshot and type in, like I would make sure, and I'm pretty sure I can just copy and paste this from Desmos. So I'm going to take that and I'm just going to try and paste that somewhere. There it is there. Ooh, it's pretty ugly, right? So actually, so that's not a good idea. I think I'm just going to type this here. So it's 50 times 0.77 to the power of, can I format this nicely? Not sure really quickly, so I'm just going to do this. I don't like it, but it's to the power of x plus 0. Yeah, there must be a way somewhere here of formatting this a little bit more nicely, but I'm just not sure exactly now where to do it. So play around with that, share it if you find it, please share it with each other. There must be a way of typing that. So is the model for a four-sided dice. Okay, six-sided dice first, everybody does that. Second, when you've done that, the teacher will allocate you a different number of sides dice, and you do the same thing again. So if I scroll through my Google Doc, like, okay, so you're going to fill out a table with six-sided dice. You're going to do the same thing with a different number of sides dice. At the end of each one, you'll have, oh, I seem to have lost my diagram, so I'm going to try dragging that in one more time. Okay, and then you're going to share this with me, right? You're going to share this with me at the end of the lesson. Yeah, so just do as much as you can, and then the last part of the exercise, there's a small table of data for you to work with and some questions to answer. Okay, hope it goes well, and I'll see you next class.